This is Ed Robinson of Kensington College, continuing in our lessons on C++ classes. Last time we discussed how we had a class and we made an instance of that class. We set the data element of I being made for, and then we access the data using these functions which accessed the data. The data, of course, is private, but public functions are used to access the private data. So we can see that we've initialized our data using the setData function. You can imagine that this happens quite a bit, initializing data of our object, and indeed it does. So we use a special function which is called a constructor. Let me just show you a constructor. So indeed we will just replace our initializing member function with a constructor which looks like this. Now you'll notice that the constructor, it's got the same name as the name of the class. In this case, this is we're using a default value of 4 here, so we don't need, if you look down here at set data, we don't need to, well, we look at the set data, we can get rid of the call to set data, because when we create this object here, it will automatically access the constructor, and you can read this line here as I equals 4, like a mathematical function notation. Don't forget the colon here and the 2 curly braces which denote our constructor. So this is a constructor. Once again, a constructor is something which is automatically called when we create an object. So let me see if that works. I'll run the code first of all. And indeed we've got a value returned of 4, so let's do that slowly and see how that works. I'll put a breakpoint here. Now as I run the code, it runs up to that breakpoint, and then if I do an F11, that should continue. And you can see explicitly the constructor is being called. And you can look and see the value of the object, the I of the object. If I just single step, this by the way means the current object, which you might see. So I continue down, and this, you can see the current object has been given the value of I equals 4. So P1 has an I which is equal to 4. And then we exit our constructor, and then I'll just continue that, and you can see that it runs and produces the value 4 using the getData function. I'll just close that, and what happens if I don't have a value in here? Let's see what happens when I run that. It should give me the value of 0 because it's just taken on the default value of 0 and been returned using the getData function. We've considered so far a no argument constructor. There's nothing been passed to the constructor. Well, what about if we want a 1 argument constructor? Well, I'll just copy this code down and modify it to produce a 1 argument constructor. And we do that by putting in a dummy variable in here, and then in here we've got int j. And once again, you can interpret this line here as I equals j. So we need therefore to call our 1 argument constructor. So indeed, I will make another object to do that called part P2, and then I will use the parentheses to pass an argument. So I'll pass it the argument of 5, for example. And I will want to print out my data, so I'll make that P2 get data. And let's just see if that works for a start. And it should produce the output of 5, which is correct. Okay, so now if let me single step from this line here. So I've already at that stage created my object P1. Now watch what happens here when I do a when I press the F11 to single step here. It goes to the one argument constructor. So it's passing the value of j is 5. J is like a dummy variable, and don't forget that means I equals j. So I is our data belonging to the class, so that this value of I, well, first of all, you see j is passed here from here. So j receives the value of 5, and then this line says I equals j. So it sets the internal data variable equal to 5. I'll just single step to continue that, and you should see that I has got the value of 5 and been returned, and then I can just continue to run that, and that should just get the data and print out the value of I, which is, as you can see. Let me show you something of a quirk, really. We've got our no arguments constructor, we've got a one argument constructor. Here we have called the no argument constructor, and here we have called the one argument constructor. What happens if I comment this out? I don't have now a no argument constructor. Well, you will recall that when we first tried it out, we didn't need a constructor, going right back to the very start of making our class. We didn't actually need this. It produces what we call a default no argument constructor. But now that we've got this, we essentially need to have this. Well, that is indeed if you want to call the no argument constructor. So you can see it's causing an error. It won't allow me to compile this. So if I were to comment it out, it does work. It should build okay. And you could try that and just confirm that that's working okay. But indeed, once you want to call a no argument constructor, you can see that it's going to cause an error, and if you tried to build that, it just wouldn't work. So let me just restore. I think what we're trying to say in general is that if you introduce a one argument constructor, then there are times when you'll need to have the old no argument constructor as well. We'll talk now about the scope resolution operator. We've made such a fuss about how these functions are part of the class, and they ought not be outside. Well, having said that, I'm going to take it outside the class. I'll just drag that out, but I'll need to indicate to the class that it is there somewhere. So I'll just control drag that up there to make a copy, and then if I provide a semicolon, then that lets the class know that that get data function is around somewhere. But I also need to give this a label, so to speak, and this is the double colon, which is a scope resolution operator. It's just saying that get data belongs to that class. And then we can build and run our program. So I'll just try running it. And once again, we've got the value of 5 as being output. You could single step that by putting a breakpoint here. You could try that yourself. Be careful of the cout. Don't forget the F10. And you should find indeed that this function is called. So that's how you place function code outside the class. I could move it here, which would be more usual actually. So it's just outside the class, and this is indicating that it belongs to the class using the scope resolution operator. Well, constructors are functions as well, so you could probably do that as an exercise, is to move the constructors outside as well, but don't forget to tell the class that there is one hanging around somewhere. So let me just try and do that. I'm going to move these constructors outside. If I'll just cut them out of there and paste here, and then I need to and don't forget we need to put a semicolon when we're putting our prototypes in. I'll drag this one up as well. I'll just make a bit of room for it and move this one up as well and put a semicolon. We actually don't need all of that, so for our prototype, and then of course we need to specify that it belongs to the class. So now if you build and run this and then run it, and you should find that it still accesses the element 5. So to summarize, if you want to put your public functions belonging to the class, if you wish to put them outside, then you must qualify these functions with the scope resolution operator, and don't forget to put your prototypes inside, followed by a semicolon in each case. What's the point of doing all this? Well, a bit later on you'll find that it's very useful to just put all of these in a separate file, and then this thing here constitutes what we call a header. It's the class header, whereas this is all the functionality. Now you can imagine that this is a lot bigger. There's a lot more you can do with functions. It can go on for thousands of lines of code, whereas the class is quite small really when you just specify which functions you'll be using. And as I say, this is usually placed into a header file, and this is in a separate file for your functions.